now a little bit backwards, meaning we are given the square root of 2x and the square root of 5y. We are asked to multiply them. Okay, they have the same index. If they don't have the same index, I cannot multiply them. But they have the same index. So I will write the square root of this times this, 2x multiplied by 15y. So then I have the square root of, I have to multiply 2. Remember, a multiplication is commutative and associative. I can rearrange those. And 2 times 15 is 30, xy. The square root of x and the square root of y are done because power 1, index 2. But can I simplify the square root of 30? Not really, because the square root of 30 is 1 times 30, is 2 times 15, and is 5 times 6, none of which are perfect squares. So this is it. But if I'm asked to simplify the square root of 48, that's a different story. Because the prime factorization of 48, let's take it on the side, it's an even number. It's an even number. It's an even number. It's an even number. And look what I have. I have the square root of 16 times 3. Why I didn't write 8 times 6? No, because 16 is a perfect square. So then I will rewrite it as the square root of 16 times the square root of 3. I can take the square root of 16, and what do I get? I get the square root of 16 is
4.
That's it. 4 the square root of 3. This is the simplified form of the square root of 48. But we could have not simplified the square root of 30. It cannot be simplified in any way, shape, or form. 1 is not a perfect square, 30 is not a perfect square, 2 is not a perfect square, 15 is not a perfect square, 5 and 6 are not perfect squares. I cannot split 30 in any way, shape, or form. But I can split 48 into 16 and 3. One being a perfect square and the other one, category 2, carved in stone. This is it. Any questions? What about if we multiply the square root of x plus 10 by the square root of x minus 10? They have the same index. So I can multiply them. Okay, you can write the intermediate step as x plus 10, x minus 10. You have to remember from the previous module what this is. If you still FOIL it, then you don't remember factoring. Then you need more practice. What do we write x plus 10 times x minus 10? When we multiply x plus 10 by x minus 10, what do we get? A plus b times a minus b. It's a difference of squares formula. Please, what is it? It's the simplest possible formula or special product.
X plus 10 squared?
No, that x plus 10 squared is a trinomial. So the x plus 10 squared is not x plus 10 times x minus 10, right? This is x squared plus 2 times the first times the second plus the second term squared. But this is not x plus 10 times x minus 10, which is the difference of squares. So x plus 10 times x minus 10 is? What should I write here that factors into this? Anyone, please?
Well, we got negative 10x and then positive 10x. So isn't that 0? I don't know how we got 20x.
But this is not plus and minus. This is plus only. So this is not this. I was just saying that x plus 10 to the third power is a trinomial. The first term squared plus 2 times the first times the second plus the second term squared. And this is not a trinomial. This is the difference of squares. This answer, when we multiply these two, we get 2 terms, not 3. So what should I put here that factors into these two?
I don't think we know. Can you tell us?
Sure, it's x squared minus 100. X squared minus 100 factors into x plus 10 times x minus 10. I know you know this because you answered my questions all the time on the difference of squares. And what I wanted to make sure is that you will never, no one will ever, ever, ever write the square root of x squared minus the square root of 100. Never, never, ever, ever. We don't have a rule for a difference of terms under any root. This is carved in stone. This is done. If it were multiplication or division, yes, I could have split it, but never split a difference or a sum. That's never allowed. Good. Let's simplify the square root of 250. 250 is not a perfect square. So obviously I have to find two numbers, one that is a perfect square and the other one that is not. How do we present 250 as a perfect square and another piece that is not a perfect square? And remember, as factors, otherwise we cannot simplify. Don't say 100 plus 150. No, 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 no. The plus or minus cannot be simplified. It has to be a product of two factors. One that is a perfect square and the other one that is not. And this one has to be the maximum perfect square. Any suggestions?
15 and 5?
15 and 5 are not perfect squares, none. So we want a perfect square, and then the other one that is not. Let's take it on the side. It's you can write it first as 25 and 10 if that's easier. And this is 5 and 5, and this is 2 and 5. So I know exactly which one is a perfect square, and I know the remainder is not a perfect square. So I know that I have to rewrite 250 as 25 and 10. Because I can take the square root of 25 and the square root of 10, I cannot. That is carved in stone. So then what will be the simplified form here? Can anyone give us the simplified form? Yes, no? So how do I write this? Please, anybody?
250?
The square root of 25 is 5.
That's a 5 square root.
5 square root of 10. This is it. That's why we split it. So we can simplify it.
Couldn't you have done 225 and then 25? So they're perfect. Both of them perfect squares?
So you want the square root of 250 to be the square root of 225 plus 25?
Yeah.
This is done. I can never split a sum or a difference. I can only split a product or a ratio. Is that clear? Assuming that this were true, then it would have been 15 plus 5, which is 20. Is 20 squared to 50? Is 20 squared to 50?
No.
No. If we don't have these discussions, you will remember less. If we have these discussions, why I cannot do this, you will remember more. So any question is more than welcome. So again, we can only split the number or quantities in factors, because only if they're factors we can take the square root. If we split them into a sum or a difference, we're not accomplishing anything. We don't reach our target, because this is not the square root of 225 plus the square root of 25, which would have been 15 plus 5, which would have been 20, but 20 squared is not 250. But I guarantee you, if you square this, you get this. If you square 5 the square root of 10, you will get the square root of 250. Guaranteed. Let's try. Let's say we don't want to do any calculations by hand. Fine. You should be able to check if these are the same. So I plug in the square root of 250. Whatever gibberish I get, I don't care. But then 5 multiplied by the square root of 10 has to give me the same gibberish. If it doesn't, math means nothing. So that's why the square root of 250 is the same with 5 the square root of 10. And this is a very good question. You should always, if you have any difficulties, or at least at the beginning, you should always verify your work. So this is how I verify my work. Okay, I claim that the square root of 250 is 5 the square root of 10, but is it? Let me check. It's a very good point. Is it clear now? Are these steps clear? Anybody, please? Okay, so let's look now at the cube root of 81. Okay, let's say we don't know what 81 is. It's divisible by 2? No. I move on to divisibility by 3. Is divisible by 3? Yes, it is. 27 is divisible by 3. Yes, it is. Is divisible by 3? Yes, it is. But the cube root is the key now. How do I rewrite 81? And I think in terms of the cube root. So if I think in terms of the cube root, I have to think in terms of 27 times 3. Or you can write it as the cube root of 3 to the third times 3. So therefore, how do we simplify? We can rewrite it, if you like, as the cube root of 3 to the third times the cube root of 3. Please make sure that you copy the same radical. You cannot say that this is the cube root and this is square root. No, 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 no. They have to have the same index. So then, how do I simplify this? The first piece is can anyone tell us what is the cube root of 3 to the third? What does it equal to?
It'd just be 3.
Yes, very good. The cube root of 3, very good. So 3 over 3 is 1, so 3 to the first power, but multiplied by the cube root of 3. Excellent. The cube root of negative 27b to the third. You can split it if that's what you want to do first. What will this equal to?
Negative 3b.
That's it, negative 3b, and there is nothing else. We don't have to do anything else here. Any questions? As I said, this is more technique. It's not very exciting section of the class, of the topics, but it's very important. Okay, moving on. Let's see how we simplify the square root of x to the 7th. And this is page 11. Because 7 divided by what? What is in here? I don't see it. 7 divided by
2.
exactly is not an integer. I go back 1. Is that going to be okay if I go back 1 from 7? Back 1 means 6. Can I divide 6 by 2?
Yes.
Good. What is the remainder? X to which power? Because I cannot change the problem.
To the first.
Yes, indeed. Good. So now I split it. And the first one simplifies. The second one doesn't, but there is nothing I can do about it.
X to the third
Yes.
times x.
Yes. Times the square root of x. Yes. 6 divided by 2 is 3. Now, this is correct if x is greater than or equal to 0. But the correct answer will be the absolute value of x to the third times the square root of x if x is anything. So depending on what the problem is telling us, this is correct if we are told that x is greater than or equal to 0, because remember the index is even. So I have to worry about the answer. When the index is even, I have to worry about everything. I have to worry about the inside and I have to worry about the outside. If I'm told that x can be anything, this is the correct answer. If I'm told that x is only positive, then this is the correct answer. So these are two different situations. If x is greater than or equal to 0, this is correct. If x can be anything, then this is correct with the absolute value. Okay? The square root of 8y to the 8th. For now, I'm going to split in the square root of 8 times the square root of y to the 8th. This is nice because 8 divided by 2 does not give me any headache. But this is not nice because I cannot take the square root of 8 and I will be able to find two factors, meaning multiplied, not added or subtracted, multiplied to give us 8, out of which one is a perfect square and the other one is not a perfect square. How will I split 8?
4 and 2.
4 and 2, of course. Multiplied. Good. So then I will continue and write this, the square root of 4 times the square root of 2 times the square root of y to the 8th. This is the same thing. It's still the square root of 8. We didn't change the problem. But now we know that this piece will change into,
2.
we know that this piece will change into y to which power?
4th.
Yes. We do not like to have a radical inside a product. We want the radical to stay outside at the end. And I'll explain why. If we rewrite, it's not incorrect, but if I write this, I may accidentally do this. Who knows? My handwriting is not perfect by any means. So this is one of the reasons that we try to always put the square root at the end. But you can say, but this is not how we write it. We write the numbers in front of the variables. True. I agree completely. But we prefer the radical to be at the end, not to, and in order to avoid this possible confusion, because this would be incorrect. So we prefer the radical to stay at the end, if there is a radical in a problem. Okay. Moving on. -7, the cube root of 48x to the third. So -7 is -7, waiting outside patiently. The cube root of 48 is the cube root of 48. We'll discuss it in a moment. And the cube root of x to the third is nice. This is done. There is nothing I can do to -7. This is nice, but this isn't. I need two numbers whose product is 48, and one of them is a perfect cube, and the other one is not. Not a perfect square, a perfect cube.